In question number 21, the fundamental frequency of a sonometer wire of length 200 cm is 100 Hz. A bridge is now introduced at a distance of 1 cm from the midpoint of wire. The wire on the two sides are again vibrated in their fundamental mode. The beat frequency is nearly. Suppose this is a sonometer wire of length 200 cm and its fundamental frequency nu is 100 Hz. So we can write nu is equal to V divided by lambda. So in fundamental mode, the value of lambda is equal to 2L. Now it is given in the question, suppose this is midpoint, then a bridge is introduced at a distance of 1 cm from the midpoint of wire. So here the bridge is introduced and this separation delta L is given as 1 cm. So in that case, now one segment have a length L by 2 plus delta L. So its fundamental frequency nu1 can be written as V divided by 2 times L by 2 plus delta L. And for the other segment, the fundamental frequency nu2 can be written as V divided by 2 times L by 2 minus delta L. So if I find out the beat frequency, nu2 minus nu1 comes out to be 8 times nu into delta L by L. So if I substitute the data, 8 into nu is 100 into delta L is 1 and L is 200. So if I solve this, it comes out to be 4 Hz. So option 1 is the correct answer. Let's move to question number 22. In question number 22, a convex lens of focal length 20 cm and another convex lens of focal length 40 cm are placed coaxially. What should be the distance d between lenses so that final image of object O is formed on the object itself? So in order to have the final image formed on the object O itself, it means the rays after refraction from the second lens must fall normally on the plane mirror. So in order to have this, it means the image formed by the first lens must be at the focus of the second lens. So in that case, suppose this is the situation, this is the focus point of second lens, then after reflection from the plane mirror, the ray will follow its path and the image will form on the object itself. So I have to find out where the image is formed from the first lens. So in order to calculate this, for the first lens, I can say that the value of U is equal to minus 40 cm and the value of F is equal to plus 20 cm. So if I apply the lens formula for the first lens, 1 upon V minus 1 upon U is equal to 1 upon F, then from here the value of V comes out to be plus 40 cm. So this is 40, and since this is the focus point of the second lens, this separation is also 40. So D is equal to 40 plus 40, so it comes out to be 80 cm. So option 1 is the correct answer. Let's move to question number 23. In question number 23, a ray of light is refracted through a glass sphere of refractive index √3 in such a way that it passes through the extremities of the two radii, which make an angle 120 degree with each other. If delta is net deviation of ray, then value of delta is. Let's analyze the situation. Suppose this is a glass sphere of refractive index √3. Now, suppose at this point the ray incident at an angle I. Since the rays move from air to glass medium, so it bends towards the normal. So let it move in this way, and this is the angle of refraction. So as the ray reaches this point, again I am drawing the normal, then this angle is also R because it is an isosceles triangle, and if it is the angle of incidence at this point, then the angle of refraction at this point is this, which is equal to I. So it is given in the question that this angle is 120 degree. So if this angle is 120 degree, then summation of these two, that is 2R, must be equal to 60 degree. So from here the value of R comes out to be 30 degree. Now if I apply Snell's law at this position X, then I can say that 1 into sin I is equal to mu, that is √3 into sin R. So sin I is equal to root 3 into sin r is 1 by 2. So from here the value of I comes out to be 60 degree. Now the deviation of ray at this point is I minus r, and the deviation of ray at this point is further I minus r. So total deviation delta is equal to 2 times I minus r, and both deviations are in same sense. So if I substitute the value of I and r, so this is 60 degree minus 30 degree. So if I solve this, it comes out to be 60 degree. So option 3 is the correct answer. Let's move to question number 24. In question number 24, in a Young's double slit experiment, the coherent sources are spaced 2D apart and the screen is placed at a distance d from the slits. If fifth dark fringe is formed on the screen opposite to the slit, then d is equal to. So this is the arrangement. Suppose this is slit S1, this is S2, and this is screen. This separation is capital D. Now it is given that the fifth dark fringe is formed opposite to one of the slit. So let this separation is 2D. So if I take the part difference, then it is 2D sin theta, and this is equal to 9 times lambda by 2 for the fifth dark fringe. So since this angle theta is very small, so I can say that sin theta is approximately equal to tan theta, and it is equal to this separation d by capital D. So if I substitute this, so 2d into d by capital D is equal to 9 by 2 lambda. So from here the value of small d comes out to be 3 by 2 under root lambda into d. So option 3 is the correct answer. Let's move to question number 25. In question number 25, the light source S is over the center of a circular fixed opaque plate of radius 1 meter and at a distance A is equal to 2 meter from it. The distance from the plate to the screen is 1 meter. Rate of increase of diameter of shadow formed on screen if source moves towards the screen with a speed 1 meter per second at the given instant will be. So at this instant, if I draw the region of shadow, then this is the region of shadow, and let the diameter of this shadow region is capital D. Let at this moment, at any time t, this separation is x. So from geometry of these two triangles, I can say that d by 2r is equal to x plus b. This separation is x plus b divided by this is x at that moment. So from here the value of d comes out to be 2r by x into x plus b. So if I differentiate this, dd by dt comes out to be minus 2br upon x square into dx by dt. So I have to find out the rate of increase of diameter at an instant when x is equal to a. So if I substitute the data, dd by dt, this comes out to be 2 into b, that is 1 into r1 divided by x equal to a, that is 2 square, and dx by dt is given, that is 1 meter per second. So if I solve this, it comes out to be half meter per second. So option 4 is the correct answer. Let's move to question number 26.